The National Center for Atmospheric Research scientists study a wide variety of problems in the atmospheric and oceanic sciences, as well as in solar physics. Supercomputers are used to model or simulate the Earth's climate, the oceans, chemical concentrations in the atmosphere, clouds, storms, wind shear, and the effects of the sun on the atmosphere. Satellites and other observational systems provide data that can be compared to that produced by models, as well as for other purposes. Modeling physical or chemical processes on a global basis requires tremendous computational resources and generates a huge volume of data. This is also true of the observational systems. The Scientific Computing Division provides a computing facility tuned to dealing with the special requirements of our research. 2 Cray YMP multiprocessor supercomputers support an intense modeling and analysis activity. What we call the mass storage system acts as a repository for most of our data, and it currently has over 20 terabytes, or 20 million megabytes of information stored on it. How can scientists deal with such an enormous volume of data? One answer is visualization, which is a broad term and basically means that a collection of data is converted into a picture. But most of our research involves time-evolving processes, such as a 50-year climate simulation or the development of a storm. One picture tells only a small part of the story, so many pictures are combined to produce an animation. Now the scientist can view processes on the Earth as if through special glasses and in elapsed time. In addition to the computing environment, SCD provides visualization tools and services, one example of which is NCAR Graphics. NCAR Graphics is a software package for scientific visualization. We support its use on a wide variety of systems, ranging from low-end workstations all the way to supercomputers. NCAR Graphics is widely used around the world and is still in demand after 20 years. We also provide specialized systems for scientific visualization. This room is one of our visualization labs and is aimed at providing scientists with a high-performance environment for visualization and animation production. Using the systems you see here, a scientist can experiment with an animation, and once having created something suitable for presentation, can annotate it and produce a videotape that can be used in a presentation or a conference. SCD also provides tags, text and graphics servers, a network resource that a scientist can send imagery to and receive back microfiche, color or black and white slides, or motion picture film. Early next year, videotape will be offered as a new output, giving local and remote atmospheric scientists the ability to produce high-quality animations simply and effectively. Visualization is all about seeing, so enough talking. Let's take a look at some examples. The first example is a special case of one of the most intense computing activities, climate modeling. The U.S. DOE is building a nuclear waste repository at Yucca Mountain, Nevada. A requirement for this repository is that no climatic change should occur during the next 10,000 years that would cause radioactive material to be released to the environment. Scientist Starley Thompson is conducting simulations of future climatic scenarios to see if this requirement can be met. Due to their incredible computational requirements, global climate models must be run at rather crude spatial resolutions which are in fact too crude for this particular analysis. So Starley has coupled a global climate model with a finer mesoscale model, which deals specifically with the region of interest, Yucca Mountain. This is referred to as a nested model, and the global model feeds the smaller, finer resolution model. The simulation is run on Cray supercomputers, and the resulting data is visualized on workstations. Visualizations are then animated on a PC-based animation system. You're now viewing the running model. Visualization allows the scientist to see the dynamics of both models and also their relationship, as well as specific results in the region of interest. Ocean modeling is closely related to climate modeling and just as computationally intense. In fact, new climate models are being developed that couple earlier atmospheric models with ocean models. Bert Sempner of the Naval Postgraduate School and Robert Chervin of NCAR have collaborated to develop a parallel ocean climate model which runs on NCAR's supercomputers. Mike McCann, also of NPS, developed custom software for visualizing the data produced by their model. Mike moves data over the internet to his workstation in Monterey, where he creates visualizations and animates them on his workstation. Once he settles on a visualization scheme, his colleagues at NCAR, among them Tom Betke, use SCD's visualization lab to produce videotapes of the animations you're viewing now. Visualizations of salinity and temperature provide the user with a clear view of ocean dynamics, eddies, and flow. The results depicted here correlate closely with satellite observations as well as field measurements. The animated visualization makes it easy to understand dynamics of the ocean that simply cannot be easily inferred by viewing still imagery. Joe Klemp has developed a mesoscale cloud model, as well as a visualization tool called PolyPaint, which he uses to visualize the model. Mesoscale refers to the modeling of phenomena at a resolution of less than 1 kilometer. PolyPaint is used to construct a three-dimensional surface, which represents the visible cloud from cloud model data. It's shown in white. Then another surface, representing rain, is constructed and shown with the visible cloud as a pink transparent shell. This image shows a well-developed cloud, but the time evolution of the entire process is of interest, so we view an animation. While some visualization tools emphasize quantitative information, this example shows more qualitative information. The shape of different variables, their interrelationship, and how they evolve in time are all studied through visualization. Visualization is certainly the best and perhaps the only way to comprehend vast amounts of data, such as routinely encountered in atmospheric and oceanic sciences. In dealing with large amounts of data, it is literally the case that one picture is worth thousands of numbers, and an animation is worth millions, even billions of numbers. Consequently, NCAR will continue to maintain its visualization capabilities at or near state-of-the-art.